Hello everyone, welcome to Enmak Academy. Today we'll be looking at calculus. So we are going to start a series on calculus. So sit back and enjoy. Let's dive in. We can't start calculus without looking at trigonometric functions. So let's look at some of the trigonometric functions. Alright, so let's take a right angle triangle. Okay, this is a right angle triangle. So let's call this angle alpha. And then let's call this side A, this side B, this side C. Another interesting thing you should always remember when it comes to trigonometry is SOHCAHTOA. So I'm going to write that on the side. Where the SO stands for sine of the angle being equal to the opposite over hypotenuse. What do you mean by opposite? The side which is directly opposite where the angle is. So this side is the opposite. The side which is where the angle is becomes the adjacent. And then the longest side is definitely the hypotenuse. Alright. So if you are looking for sine of the angle, so sine alpha is equal to, we know sine is opposite over hypotenuse. So that will be equal to A over C. And then cos alpha. Cos is adjacent over hypotenuse. Adjacent side is B, hypotenuse is C. And then tan alpha. Tan is equal to opposite over adjacent, which is A over B. A over B. Another thing to take note of is that tan is equal to sine over cos. Let's see whether this is true. So we already know that sine theta is equal to A over C over cos theta. Cos theta is also equal to B over C. So when we divide A over C by B over C, we get A over B, which is equal to what we have here. So it means that tan theta, or tan of the angle, is equal to sine over cos. And then we would also look at their reciprocals. If you have 1 over sine theta, so here I'm using alpha, 1 over sine alpha, that should be equal to cosec alpha. And then 1 over cos alpha is equal to sec alpha. And then 1 over tan alpha is equal to cot alpha. So I believe you'll be able to remember all of these ratios, the 3 ratios as well as their reciprocals. You should be able to remember them. So it means that with this particular right angle triangle, if I had drawn it this way, where alpha was here, then I have my right angle triangle. Then means that this side will be my adjacent. Let me call that a capital A, but that's where the angle is lying. The side which is directly opposite the angle becomes the opposite side, and then the longest side is always the hypotenuse. So you please take note. The next thing that we'll also look at is the angles. So with the angles, we'll be looking at degree measure as well as the radian measure. when we talk about degree measure, you are referring to this particular one measures the size of the angle in an anti-clockwise direction. And then we also look at the radian measure. Radian measure measures the arc length. It measures the arc length generated by the angle. There are some special angles you need to take note of. We have something like sine 30 degrees. Sine 30 degrees is equal to half. But you can get this on your calculator, so it's not really a problem. Cos 30 degrees is equal to root 3 over 2. Tan 30 degrees is equal to root 3 over 3. Now this answer is the same as cos 60 degrees. Cos 60 degrees will also give us 1 over 2. And then sine 60 degrees will also give us root 3 over 2. How about tan 60? Tan 60 is equal to root 3. But like I said, you can get these angles with your calculators. With the radian measure, like I said, it measures the arc length generated by the angle. So 360 degrees gives us 2 pi radians. So that means that 180 degrees is equal to a pi radians. And then 90 degrees is pi over 2. So anytime you see pi over 2, just know it's equal to 90 degrees. 45 degrees would give us pi over 4. 30 degrees gives us pi over 6. So you ask, how did I get 30 to be pi over 6? You can just do the proportion. So if 180 degrees is equal to pi radians, then 30 degrees will be equal to what? So here I can just cross multiply. So I get 180 times x. 180 times x equal to 30 pi. Since I'm looking for x, I divide through by 180. This cancels. So my x will be equal to 3 goes into 18 6 times. So I get pi over 6. So that's how we can switch from radians to degrees and vice versa. So if I have an example like this, if I'm to find sec pi over 3, the value of sec pi over 3, we know sec is equal to 1 over cos. So I can rewrite this as 1 over cos pi on 3. So 1 all over cos pi over 3. And cos pi over 3 is equal to 1 over 2. So this gives me 1 divided by 1 over 2. And this is equal to 2. So you can join us for our next class on limits. Make sure you like, share, and subscribe. See you.